The next problem is a problem about related rates. This is part of the review for the second midterm. A tractor traveling at 3 meters per second pulls a rope attached to a bale of hay through a pulley with dimensions indicated in the figure below. Question is, how fast is the bale rising when the tractor is 5 meters from the bale? So the picture we have is the following. So here is this is the tractor, and the distance here from the bale of hay is represented by this quantity here, x. This is the horizontal distance at any given point from the top of the tractor to the pulley. It's 4.5 meters, and the distance from the ground to the pulley is 6 meters. And so what we're asked to find here is that the speed at which the bale is rising. So how fast the bale of hay moving upwards when the tractor is 5 meters away from the bale. So when x is equal to 5. So that's all the information we have. So we see as before that we will have to use some sort of constraint and to relate the speed of the tractor and the speed at which the bale is rising, and use implicit differentiation to obtain that information. What is the first step that we discussed in the test? First thing we said we needed to do, so our first step, step 1, is to find and to identify the relevant variables. Here we're talking about x, which is the horizontal distance from the tractor to the bale of hay. H is the height above ground of the top of the bale. Now, okay, so these are the two relevant quantities here. So we need to relate them somehow, and we need to use that information together with implicit differentiation, the data we're given, to find a relation between the two velocities here that play a role in the problem. So the first thing now, after we've done this second step, is record what we know. So what we know is the first thing that we know is that the speed of the tractor, so the speed at which the x is increasing, so you're moving away from the bale, is 3 meters per second. See, as the tractor here pulls, x is getting bigger, and the speed, so this is the horizontal speed, the x here is the same quantity as this over here. So as x is moving, so that tells you the speed of, the rate at which x is increasing. It's telling you the speed of the tractor at any given time, and that's supposed to be constant and equal to 3 meters per second. So that's part of the information that you already have, 3 meters per second. So that's one piece of information that we have. So what do we want here? So we want, in terms of these variables, we want to know what is the h dt when, so is the height. See, the height here is changing, is increasing. So this quantity here is getting bigger as the bale of hay is being pulled by the tractor, and as it gets larger, it does so at a certain speed according to how far away from the ground it is, and it depends on the velocity of the tractor which is pulling. Okay, and so what we want to find out is the HGT when, and this is the data of the problem, when the tractor is 5 meters from the bale. So when x is equal to 5. This is what we're interested in. So when x is equal to 5, so when the tractor is 5 meters away from the bale, we want to find out how fast is the hay moving upwards. So we need now, what do we need now? We need a relationship between the two variables. So the geometric, as we said, is most often this relation is a geometric relation. So if we go back to the drawing, what we'll see is that we're not given, if you read the problem again, you'll see that we're not given the length of this rope, but that's actually relevant. This is material. The important thing that we need to keep in mind is the rope cannot be stretched, and as such, I mean, this total length here, let me just pick a different color. So this, well, let me just, something will be a little bit more clear. Maybe blue, or maybe green. No. Okay, so this quantity plus this quantity here is going to be constant for all time. Right, so the total length of the rope. So we know what is the geometric relation. So the geometric relation is the length of the rope remains constant. Okay. And what is the length of the rope? It contains two things. So the length L is going to be equal to to the sum of two contributions. The first one is going to be given by the use of Pythagoras. This one is just x squared, the square root of x squared plus 4.5 squared. And the other one is just 6 minus h. And so we have the total length of the rope is the square root x squared plus 4.5 squared plus 6 minus h, and that should be constant for all time. And as such, what happens when we take derivatives with respect to t on both sides? The derivative of L is 0 because it doesn't change with time. And what do we do here? We apply the chain rule. So we apply the chain rule for the first term, and we get 1 over 2 times the square root of x squared plus 4.5 squared. Now times the derivative of what's inside, which is 2x, and that's a derivative with respect to x. But we're taking derivatives with respect to t, so we need to multiply times dx dt now. So the derivative of x with respect to t. And then from here, we take the derivative also of 6, which is 0, and minus dh dt. Okay, so finally, well, we can cancel these 2's out. Finally, what we obtain is the dh dt is equal to x times dx dt divided by the square root of x squared plus 4.5 squared. So that's our formula. So but now we use the data we have. So when x is equal to 5, we're asked to compute the dt when x is equal to 5. And we also know that the dt doesn't change, it's always 3 meters per second. So we have, and we just substitute these two quantities. This one, so this value in here, and x equals to 5 in here, and we get that dh dt is equal to 5 times 3 divided by, we also need to plug 5 in here, so 5 squared, 25, plus 4.5 squared, and this, I mean, if you use a calculator, well, this is 15 on the top, divided by this square root, this is approximately 2.23 meters per second. And that is your final answer. Okay. Okay, so that's pretty much the review now. For the exam, if you have more questions, feel free to ask me. That's it.